Hi everyone, welcome to another episode here at Temple Aaron, where we're going through the process of replacing this steam boiler. This is obviously the new boiler. You guys have seen the other videos, I hope. If you haven't, go check out the channel. It is Temple Aaron Boiler Replacement on YouTube. And there you'll see process from demolition of the old boiler to getting a new boiler and assembling the block and assembling the jacket and putting the controls on and all of the stuff up to this point. So right now I'm installing the pilot. This boiler has its own little pilot operating valve, which is more of a kind of a commercial thing rather than, you won't see this on residential boilers. But so out of that little solenoid valve, there's quarter-inch aluminum tubing, and that goes down and connects to the pilot. That's what conveys gas to the pilot flame. And then when the boiler gets a call for heat and needs to fire, it will send power to the little sparker that exists on the pilot. And you'll see that little white wire coming off the pilot. That will ignite the pilot flame, and then there is a little sensor that determines whether or not the pilot is on. Once it proves that that pilot is on, then it will allow gas to flow through the main valve and light the burners. So one thing I did want to point out is on the newer equipment, a lot of times on older boilers, what they would use and what was the standard for a long time was what was called a thermocouple. And you would have a thermocouple sit in the pilot flame, and it was two dissimilar types of metal that when you heat them up, it actually creates a little voltage. So you would use that voltage to power a very small little solenoid in the gas valve, and that would do two things. It would keep the pilot lit, it would keep the gas valve to the pilot open, and then it would also move a little pin out of the way to allow the main valve to open. So mechanically, the main gas valve couldn't open if that pin was in the way. And there's lots of different mechanisms for how that actually works, but that's the main thing to take away from it. Now, these work very well. They're very reliable. They do last a long time. They were the standard for many, many, many years. But they have one slight issue with them, in that if the thermocouple is hot, it will not stop supplying voltage if the pilot flame goes out for about 30 seconds, because they're still hot and they have to cool off before that voltage drops off. So now we use what are called ionization probes. And so this is a little tiny probe that sits in the pilot flame, just like a thermocouple would, but it's not relying on the probe itself generating any current. It's actually using the pilot flame itself. So I know that sounded weird, but fire is nothing more than very hot ionized gas. And because it is ionized, there's a lot of free electrons in that pilot flame, and you can actually pass current through the flame. Now, very, very high resistance, and there's a very small current that you can pass through it, but you can still do it. So what these controls do is they pass actually a very high voltage, but incredibly small current through the pilot flame to the ionization probe. When the control senses that that current is flowing through the pilot flame, then it says, there must be a flame there. So now sends power to the main burners, and the burners fire. The instant that that pilot flame goes out, for any reason, it's like flipping a switch. Now there is no ionized path for that current to travel through, so it will turn off immediately. So it's considered a much safer approach to pilot safety than a thermocouple is. So that's the modern standard. You'll see that on pretty much everything, with the exception of water heaters still use thermocouples, but they have some other safeties on them that make those a little bit safer too. So and that's kind of how that works. Everything is electronic now. There's very few boilers that will work on anything that is not driven by some kind of electronic control anymore. And you'll see also to the left of that blue ignition module there's a big red button. And what that's for is the control will sense how many times in a row it tries to fire. If it fails, if it tries to light the pilot and the pilot doesn't light, or the main burner doesn't light off correctly and blows the pilot out, or anything happens like that, it will consider it a failed ignition. And there's a certain number of times it will retry by itself before it just locks out. And then someone has to come down and physically push that button to reset it and figure out what went wrong. So another aspect of safety here. So now we have 4 safeties: the ignition module manual reset. We have the flame rollout switch that if it tripped, it would have to be replaced. We have the manual reset low water cutoff that we discussed in the previous video. We have the manual reset pressure troll, also in the previous video. All of these things have to be working correctly for the boiler to even fire. So compared to an old coal-fired boiler where it really was just some guy sitting down in the basement keeping an eye on it, these are very, very safe, especially when you consider that you don't have someone sitting here watching this all the time. That's not the standard anymore. But back when you had to actually shovel coal into the boiler, someone did have to keep an eye on the boiler. But yeah, we've come a long ways in 100 years. But basic premise of the actual heating system still pretty much the same. So right now you'll see me constantly referring back to the instruction manual and make sure that I just double triple check, follow the wiring diagram, make sure that not only am I hooking things up correctly according to their color, I'm also tracing back and making sure that those colors are correctly connected, because I've run into it before where the boiler manufacturer, someone screwed up on the assembly line and had the wrong color wire and in the wiring harness, and I had to actually shift stuff around to connect it correctly. So you always double triple check, because if you hook this up wrong, you run the risk of blowing up a transformer or control, and then you have to deal with the delay in getting that part and all that stuff. So don't want any mistakes. So now you'll see me installing the wiring harness that goes through all the the pressure trolls and the low water cutoffs and the draft switch and all that. Again, it's just a big long series circuit. All of these switches have to be working. Everything has to be closed for it to fire the boiler. If any one thing goes wrong, none of this will work. And really, it's one of the big advantages of the more modern electronic controls is that it's pretty tough to actually make a boiler fire. A lot of things have to be right for it to fire. So, and in my experience, these controls are very reliable. I've never had one fail in any kind of situation where it made it unsafe. They always fail just off. So that's when I get the call that, hey, heat's not working. Come figure out what went wrong, and then sit there and trace it all out with a voltmeter and figure out which control is bad. So I guess that's a rundown on everything. I'm not going to tie any of my wires up into their final positions and put zip ties on them and stuff until I actually fire the boiler and make sure that it's all working. Because if there is something wrong, say there's a nick in a wire or something like that I have to repair, it makes it a lot easier as it is now when it's all loose and open, where I can just quickly make a repair if I need to. So that will look kind of messy until it's all actually ready to go. But yeah, I think that's it. If you guys have any questions, feel free to email me at templeaaronboilerreplacement@gmail.com. And for future videos, the YouTube channel is obviously Temple Aaron Boiler Replacement. So hope you guys have a good day, and hope you enjoyed the video. If you have any questions, email me, and we'll go from there. I'll get back to you.